Hi! We're going to talk about the history of IPv6 along with explaining its parts and purposes. Here we go! The current version of the Internet Protocol IPv4 was first developed in the 1970s, and the main protocol standard RFC 791 that governs IPv4 functionality was published in 1981. There were definitely unprecedented expansion of Internet usage in recent years, especially by crowded and compacted countries like India and China. Due to this, the shortage of address space availability that's about to happen was recognized by 1992 as a serious limiting factor to the continued usage of the Internet run on IPv4. As you can see on the left chart, in 1985, 1/16 of the total space was used. Then in 1990, it has increased to being 1/8 of the total space used. In 1995, a quarter of the total space was occupied and has even increased to being half of the total space used for 2000. Halfway through 2002, 2/3 of total space is used. Here's another visual representation. If you look at the bar graph on the right, you can clearly see the diminishing of our IPv4 space from left to right. While all this was happening, our Internet Engineering Task Force, or IETF, initiated as early as in 1994 the design and development of a suite of protocols and standards now known as Internet Protocol version 6, or IPv6. It is to be the worthy tool to phase out and replace IPv4 over the coming years. There is an explosion of sorts in the number and range of IP-capable devices that are being released in the market, and the usage of these by an increasingly tech-savvy global population. The new protocol, IPv6, aims to effectively support the ever-expanding Internet usage and functionality, as well as address security concerns. IPv6 uses a 128-bit address size, as you can see, compared with the 32-bit system used in IPv4. This allows for as many as 3.4 times 1038 possible addresses, enough to cover every inhabitant on planet Earth several times over. The 128-bit system also provides for multiple levels of hierarchy and the flexibility in hierarchical addressing and routing. Now let's hop on to creating IPv6 addresses. I'll explain you the address parts and its purposes. We're going to talk about IPv6 addressing and subnetting. Here we go. As you can see, an IPv6 address has 128 bits, 4 times more bits than IPv4. It's arranged as 8 blocks of 16 bits and they are colon separated. So that's 1, 2, 3, 4, 5, 6, 7, 8. Now where the X represents 16 binary bits, you can think of it as looking this way. Now, using the same 128-bit address, here's how it'll look like converted to its hexadecimal equivalent. Let me show you. So 8145.010c 0000 0000 1100 1A06 8800 and 0001. If you were to write the IPv6 address as hexadecimal, here's how it's going to look like. There you go. Now, hexadecimal addresses are expressed as 8 groups of 4 and can range from 0 to FFFF. It's also not case sensitive. Now let's talk about zero suppression. This is a way to simplify IP addresses by suppressing leading zeros. Let me give you an example. Notice how the 4 zeros are compressed to 1 0, and the zeros here are all gone, which left the 1. That is what we call zero suppression. The other one is called zero compression. Let me show you how it looks like. Now this is a way to skip writing the 4 blocks of zeros and just hide the consecutive blocks. You can only do this once in an address and it'll look like this. Notice how the zeros are gone, and once you write it in the final form, it will look like this. There you go. IPv6 address can be broken down into a network portion and host portion. So let me show you how that looks like. So the first 64 bits is the network portion. The last 64 bits is the host portion. IPv6 host portion is always 64 bits and it's automatically calculated. The network portion is also going to be 64 bits. Now, in CIDR notation, it's commonly written with a slash, as you can see here, and the number of bits in the network address, which is normally 64. In subnetting, you would use last 16 bits in the network address as the subnet address and put a /48 to indicate that only 48 bits are in the network address. As you can see, the first 48 bits is the network, last 16 bits is the subnet, and the last 64 bits is the host portion. And here's the /48. Now let's see if you can remember some of the stuff we've discussed earlier. In 1994, who initiated the design and development of IPv6? Care to take a guess? It is the Internet Engineering Task Force, or IETF. Next question. How many total bits does an IPv6 address have? The answer is 128 bits. Well, that's all I got for you. Remember, the best way to predict future is to create it. Have a great day.